You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Is recycling for real? Welcome to the show that separates fact from fiction, science from pseudoscience, real history from fake history, and helps us all make better life decisions by knowing what's real and what's not. In this episode, which comes out right before Earth Day, we're going to do a sort of State of the Recycling World address. Every so often there's big news about recycling, so it makes sense to check in every once in a while to see what's the current state of things. The famous Chasing Arrows logo, 3 arrows chasing each other around in a triangle, promises a closed cycle, no waste, no inputs. Obviously that's an idealization, but efficiency should always be the goal. Beyond the obvious environmental concerns, efficiency puts money in all of our pockets. How are we doing? Basically, we want to find out if recycling a given material is a net win or a net loss. And deciding what's a win and what's not is really the first question. You could look at it from a purely financial perspective, or you could look at it from a purely environmental perspective, or some combination of the two. Recycling requires a lot of energy, including all the logistics of transportation, the materials preparation, and all the energy that goes into the actual industrial process of recycling. You have to consider the entire cycle. That includes a ton of variables, and those variables are different in every location and in every industry and material type. Compare recycling bottles in Texas to recycling the same bottles in Alaska. One might make a lot of sense, the other might not at all. So when I talk about this subject in a short format like Skeptoid, pretty much every given little fact is going to be misleading because it's most likely an average that doesn't truly represent any real-world situation. So consider that to be my big leading disclaimer. The best we can do is give general trends. I decided to organize this exploration by type of material. We'll start with products that recycle well and finish with those that don't. And this isn't a comprehensive list because Skeptoid is a short show, so we'll just hit some of the highlight materials. Beginning with steel. The world recycles over 1 billion tons of steel every year, as its chemical properties make it infinitely recyclable. We build a lot of stuff with steel, and we also scrap a lot of things made from steel. And about 40% of total steel produced is recycled. The savings are huge, and so by weight, steel is the single most recycled material on Earth. This is despite the fact that steel is extremely energy-intensive to melt, requiring 3,500 degrees C. It costs a lot to create temperatures that high, but the savings are worth it. This is a nice little fact, but there are very few opportunities for consumers to carry their steel girders or railroad tracks down to the local recycling center. This is something that's done almost entirely at the industrial level, so it's not something the average person needs to worry too much about. As long as it saves industry money, it'll continue to be recycled at every opportunity. Cardboard boxes. Cardboard boxes are one of the most recycled materials, with about 90% of all cardboard getting recycled. It's lightweight, so transportation costs are minimized. The energy required to process it is low, since no high temperatures are needed. And there's always demand for cardboard, as its use is so ubiquitous that recycling it almost always makes financial sense. So, yay for cardboard. Aluminum cans. About half of all aluminum cans in the U.S. get recycled. Aluminum requires only 660 C to melt, while extracting new aluminum from raw bauxite ore requires 1,000 degrees C. And that's a big difference in the energy needed. In fact, the savings are huge. Recycling aluminum requires only 5% as much energy as making new aluminum. So recycling cans saves manufacturers a ton of money and greatly reduces the carbon footprint. It's also pretty light to transport, so the logistics part of recycling is not too bad. Expect to see more and more beverages being sold in aluminum containers. Newspaper. Newspaper and other similar paper products are reasonably recyclable. The fibers can be recycled 5 to 7 times before they break down too much. About 2/3 of paper gets recycled, and that's great. The interesting thing about paper, and what makes it more important to recycle than most other materials, is that when it's discarded, it breaks down into methane. Methane is probably the single most important greenhouse gas to reduce right now, so throwing your paper into the recycle instead of the trash is an important move. Glass. Glass is nice because it's 100% infinitely recyclable. All you have to do is separate it by color, as recycled glass typically retains its original color. Crush it up, crushed glass is called cullet, and melt it. The worst part about it is that glass requires a really high temperature to melt, about 1500 degrees C, and achieving that high temperature takes a lot of energy. However, it's less energy than it takes to make new glass from the raw materials, silica, soda ash, and calcium carbonate, which requires 1750 degrees C. Every 10% of cullet that you add to new glass manufacturing results in a 2 to 3% energy savings, so making glass from pure cullet requires only 70% of the energy needed to make glass from raw materials. In general, this translates to a 30% reduction in carbon emissions. Economically, though, it's okay, but not fantastic. In the United States, we use mostly single-stream sorting, where all materials are collected from consumers in a single bin, then sorted at a recycling center, and that sorting can be expensive. There are only about 60 to 65 MRFs in the U.S., material recovery facilities, that process glass into cullet, and even fewer that manufacture glass from cullet. And so often it has to be transported long distances, and glass is heavy, so this is expensive. As a result, only about 30% of glass gets recycled in the U.S. Plastic. Finally, we come to the material you're probably most interested to hear about: plastic. While it may be the most interesting, it's also the most complicated, by far. If you haven't already heard about it, for the past 5 or so years, quite a lot of investigative journalism has revealed that for decades, oil companies have invested in disinformation campaigns persuading the public that plastics can and will be recycled. Documents have proven that since the 1970s, the oil industry knew that the recycling of plastic would never make economic sense. Yet, they got everyone to stamp the chasing arrows into every plastic item. Consumers bought more plastic, believing it would be recycled, and industry made money selling more new petrochemical-based plastic. It's been yet another iteration of the Merchants of Doubt story. Tobacco companies knew their product was carcinogenic, yet advertised to the contrary, and oil companies knew their product was the main driver of global warming, and yet spent heavily claiming the opposite. And what they knew in the 1970s is still true today. Although the majority of plastics can be recycled, almost none are, because it's not even close to being economically feasible. There are 2 exceptions to this: PET and HDPE, most familiar as the plastics used to make 2-liter soft drink bottles and 1-gallon milk jugs, are often but not always recycled, and it often, not always, makes economic and environmental sense to do so. There's usually a market for these materials, and the processes are relatively efficient. Here's the trick you need to know. In the center of the Chasing Arrows logo is a single digit, 1 through 7. 1 and 2 are PET and HDPE. Any other number, 3 to 7, will almost certainly not be recycled. Yet, people see that logo and think that's all they need to know. They assume it'll be recycled, and they buy it, and throw it in the recycle bin when they're done. Few people check the number, but the number is what's important. 3 through 7 are going to end up in a landfill, or get burned to generate power, or in some countries, are likely to end up in the ocean. The reasons are complicated and multifactorial, but the basic reason 3 through 7 get discarded is that the combination of the costs of the chemical processes needed, the energy requirements, the low quality of the recycled plastic, and the market conditions for new versus recycled raw materials combine to make them too expensive and wasteful to recycle. In conclusion, the United States has 2 problems that make recycling a less attractive alternative here compared to many other countries. The first is one that we can't do much about, and that's its physical size. It's big and spread out, and logistics are always going to be correspondingly more expensive. The collection and transportation of recyclates is always going to be a bigger problem here. The second is how deeply embedded the single-stream collection model is throughout our infrastructure. Single-stream collection, where all recyclables are thrown together, has inherent problems. Materials contaminate one another and are rendered unrecyclable. The equipment and labor needed to separate the different materials gets really expensive, and the process itself often ruins otherwise recyclable materials, like breaking glass bottles and contaminating other stuff. If people did more pre-sorting and collection agencies were set up to handle it, that would bring prices down and efficiency up across the board. But single stream also has advantages that probably mean it's here to stay. Collection is much cheaper, participation is higher because it's easier, and it's inherently flexible in that more types of materials can be accepted. And so, there we have our State of the Recycling World address. It's not a super rosy picture, but it is what it is. I wanted to wrap this episode with recommendations on what the average person can do. But honestly, there isn't very much that would be meaningful. The situation is driven more by market forces than by individual activism. Pay attention to the numbers in the Chasing Arrows logo and avoid the 3 to 7s. When you have them, throw them in the trash instead of the recycle. And remember the old saying, we do not inherit the earth from our ancestors. We borrow it from our children. We continue with more on the scandal in plastic recycling in the ad-free and extended premium feed. To access it, become a supporter at skeptoid.com/go-premium. A great big Skeptoid shout-out to our premium members, including Swiss FileMaker developer Christoph Kaufmann, Grass Valley Geode, Clan Frame, and Mark Jansen. Get the Skeptoid books. They make great bathroom reading, and they're awesome gifts for people who don't listen to podcasts. And that's still most people. Get them in our online store at skeptoid.com/store. And also, check out all the other cool stuff there. I'm not even going to tell you. Just go take a look. It's awesome. Skeptoid.com/store. Skeptoid is a production of Skeptoid Media. Director of Operations and tinfoil hat counter is Kathy Reitmeyer. Marketing guru and Illuminati liaison is Jake Young. Production management and all things audio by Will McCandless. Music is by Lee Sanders. Researched and written by me, Brian Dunning. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.